So guys, for section 2.1, I wanted to look at this idea right here. There really weren't any good examples for this within the book examples, so I thought we could just look at some of these together. So here's kind of the main idea that they're wanting you to see on this. If they want you to sketch a graph of the derivative, mainly our focus is, well, keep in mind derivative is slope, right? So mainly the focus is, what are the slopes? Are they positive or negative? We're really not going to get a very detailed graph out of this, but we can at least get some general ideas of the graph. Okay, so the main thing I see on 37 is I can see that in all these locations right here, I have a negative slope, right? Because it's a downward portion of the graph. So everything up to a value of 4 has a negative slope. Well, what does that mean in terms of a graph, right? So if I'm going to graph negative numbers, right? Negative numbers mean I'm graphing below the x-axis. Positive numbers, like I see on this side of the graph, mean I'm going to graph numbers that are above the x-axis. Okay, and so that's really kind of the main ideas that we're trying to look at on this. Anytime you see this guy right here, what always occurs between a switch from negative to positive, you would have to pass over a zero slope, right? And so right here I'm seeing this zero slope where x equals 4. So in other words, at 4, let me write on this so I don't write all over this page. So at 4, where x equals 4, I can see that my slope is 0. Everything to the left of 4, so where x is less than 4, I'm seeing slopes that are negative. And everything that's greater than 4, I'm seeing slopes that are positive. And they're not constant, right? These are changing slopes because this is a curve, right? It's not a line. These are going to have constant slopes, but these are changing slopes that we see on this. So here's just the general idea. So all they want from us is, let's draw a graph that at least represents this information. It doesn't have to be a perfect point-for-point graph. They just want us to show that we understand what we're seeing in terms of slope. So if I were to represent this on a graph, the main idea is where x equals 4, I should see a slope of 0. So in other words, at 4, I want to represent that with a 0. So in other words, 4, 0. Everything to the left of 4 should be below the x-axis, and everything to the right of 4 should be above the x-axis. Okay, and so what we're seeing on that is, so I want to draw something, and notice it does change from negative to positive, right, with this increasing positive slopes that we see over here. So the general idea is, so everything to the left of 4 needs to be in the negative area of the graph, below the x-axis, and then everything to the right of 4 would be above the x-axis. And so that's where we're getting a line that looks something like this. Now, if you really think deeply on this, you can get some more details, right, as far as this is concerned. So for example, this is a parabola. We know that the left side is symmetric to the right side, right? So just based on that idea, I know that the left side of this graph should mirror or equal the right side of this graph, right? So whatever I'm seeing to the left of 4, which is this line right here, should have a mirror image on the right side of 4, but in the positive area, right? So in the negative area, a mirror image would be drawn like this. But because it's positive, it's reflecting up to here, and now I can see it in the positive realm of the graph. Okay, and so there are definitely some more details like that we can understand from this, but these are by far the main ideas that we're trying to show within this graph right here. The other thing I would mention on this one is, again, notice that these graphs, right, or sorry, these slopes go from increasing to decreasing. This is a steeper slope, and over here, this is a less steep slope, right? So in other words, I'm going from sort of a more extreme to a less extreme as I approach 0, right? And so that's why we're kind of going from the more extreme numbers these larger negatives all the way up to smaller negatives as we approach 0, and then the opposite happens as you go from smaller positives to bigger positives, right? We're going from smaller positives to bigger positives. So again, we can certainly get a lot out of that, but when we start thinking about the slopes, but here's the main idea. So let's look at a couple more. So if I go to 38, one thing that we're going to notice on this is the same idea, but the difference is now these slopes are constant because it's not a curve, right? So if I'm looking at now a constant slope, in fact, we can even figure out the slope of this because it's a line. This goes down 1 over 1, down 1 over 1. So the slope to the left of 4, so everything less than 4, my slope is, for x is less than 4, my slope is always -1. Where x is greater than 4, so on this portion of the graph, my slope is always +1, right? It is a constant slope because this is linear. So on that side, my slope is always +1. Well, what's going on at 4? If you get a point, right, a vertex like this, notice on this one, you can't draw a horizontal tangent line on this because we're going from constant negatives to constant positive. There's no curve here. Where it's not curved, where you get a sharp point like this, your slope at those points are undefined, right? And I don't know that that was well explained yet. But anyway, that's what we're seeing on this. So at 4, so where x equals 4, my slope is really undefined because you cannot draw a tangent line to represent a slope at this kind of a point on a graph. It would need to be curved or linear like this. So this one we could do it on because it was curved, right? You're getting these evolving slopes, right? These are like, and I wish I could draw all the tangent lines on here, but you're getting these tangent lines that kind of go like this, and they start sloping into that 0 as you start going through. And so that's why on a curve, they evolve into that 0 slope and then slowly work themselves back up into a steep positive. But this is not the case because these are not changing. These are constant. And so we're going from a constant negative to a constant positive. And so by doing that, we're passing over an undefined slope at that point. Okay, so anyway, so how do we graph that based on those ideas? So again, the main thing that we want to see is at +4, this graph is undefined. So I'm not putting a point right there. Everything to the left of 4, I have a constant horizontal line, right? Just think of the equation. If I just said, hey, graph y equals -1, right? Graph y equals -1. Well, how would you graph that? That would be a horizontal line through -1. So everything to the left of 4 is a constant horizontal line until I hit 4 where it's undefined. Same thing is going to happen with this guy. Remember, the slope in these graphs, in a derivative graph, the slopes represent the y values. The slopes represent the y values. So think of this as y equals +1 for everything to the right of 4. So here's +1. So everything to the right of 4 would look like this. So this would be a graph represented on this one. And again, the big idea on this one is these slopes are constant. That's why we're getting the horizontal lines, whereas these ones are changing, which is why it's not a horizontal line. It's a sloping line, right? Like we got on this one, where we got the sloping line. All right, so what about 3940? Keep doing a couple of these for anyone who's interested. Again, on this one, we're again seeing this undefined slope at the bottom of this. So where, move this over. So where x equals 0, I'm seeing an undefined slope for the same reasons we talked about for this point right there. So I have an undefined slope at 0. So where x is 0, my slope is undefined. So what about this? So this is now a curve rather than linear. So now I'm not talking about constant slopes. I'm talking about slopes that are increasingly negative, right? So this negative slope is a little flatter than what I would get right here if I drew a tangent line, right? This is a bigger negative than this. So I'm going from a smaller negative to a larger negative. But that's all negative. So everything to the left of 0, my slopes are negative. So that portion of the graph needs to stay below the x-axis. To the right of that, for the same reasons, these are positives. So where x is greater than 0, my slopes are positive. And so how do we represent that on a graph? This is not linear. These are going from smaller to bigger. Or sorry, I said that wrong. Yeah, no, that was right. So from smaller to bigger, and then from bigger to smaller on the positive side. Let's see if we can draw something that represents that information. So to the left of 0, I need to stay in the negative area of the graph, which means I am below the x-axis. I am undefined at 0, so I cannot cross over that line right there because it's undefined where x equals 0. But it still has to stay in the negative, and like we already said, it's changing, right? It's not constant. So this has to be a curved line that stays in the negative, that does not cross over the y-axis because it's undefined at that point. So the only way to draw that would to be something like this, right? It's curved, it stays in the negative below the x-axis, and will never cross over x equals 0, where it's undefined. If we did the same thing on the other side, so on the positive side, right, everything to the right of 0, my graph has to remain positive, still can't hit the y-axis because of this information. So again, the only way to do that would be something like this. So to the right of 0, it must stay above the x-axis. It must be curved because these are curved. It's not a constant slope. So it has to stay positive, can't hit that right there. So you can see what we're seeing on this would be a vertical asymptote right there. So that's what we're getting out of this. Again, I'm not doing detailed points. I'm just representing this information on the graph. Let's do one more. Might as well, right? Let's look at number 40 for if anyone's interested. So this one is limited from -2 to +2. I am looking at a positive slope to the left of 0, a negative slope to the right of 0, and right here at the peak, we're seeing a 0 slope because, again, these are sort of decreasing positive slopes, right? This is a very steep positive slope, but as I approach the middle of this graph, you can see how these tangent lines start to flatten out until I get right there, and then I get that 0 slope, and then I'm back into the negatives, and I get bigger and bigger negatives as I approach +2. So let's summarize that. So from -2 to 0, so from -2, and I'm going to say less than 0 because at 0, in fact, this is probably not an equal sign either. Because I'm kind of looking at a vertical potential point right there. So from -2 to 0, my slopes are positive. But even more than that, I want to see these as, these are positive numbers that start big and get small as I approach 0, right? So in terms of a graph, from -2 to 0, I need to somehow show a changing slope that starts big and gets smaller, right? So it's not linear because of the curve that we're going through. Potentially it could be. This is where it gets a little tricky as far as whether it's sort of a line versus something that's curved. That can be really hard to determine on something like this. I know what they want you to draw, so I'll kind of draw it that way. But these guys are, again, start big and get increasingly small. So I'm starting big here at -2, and I'm getting increasingly smaller and smaller and smaller as I hit 0. And then as I hit 0, my slope is 0, so it means I have the point 0, 0. So where x is 0, my slope is 0. And that's why we get this point right here. And then what happens on the other side? So we get a reflective image on the other side, but now on this side, they're getting increasingly negative. So this side, from 0 to 2, needs to show increasing negative values, right? So they're increasingly negative. So as I approach positive 2 from here, I'm now getting this increasingly more and more negative graph as I approach positive 2. So anyway, I hope that helps with this group of problems. Again, we're not always getting specific exact points on these. A couple times we are, but generally we're just trying to draw something that represents what's taking place with the slopes of those graphs.